Good morning one and all. Today I am going to teach about variable voltage regulator. Previously we have studied about fixed voltage regulator, that is there the output voltage is fixed. Okay, here the voltage can be adjusted. We can vary the output voltage. Okay, it is also 3-pin variable voltage regulator. Okay, there are some of the applications of variable voltage regulators. That are some of the applications, that is LM317, LM117, IC2723. Okay, so there are some of the applications of variable voltage regulator. Okay, some of the specifications of variable voltage regulator are, that is, first we can see the power dissipation. Power dissipation is 0.6 watt to 20 watt. Again, adjustable output voltage is 1.2 volt to up to 37 volt you can adjust. Okay, line regulation is 0.01 for voltage. Okay, and load regulation is 0.1, and ripple rejection is 80 decibel. Okay, here this is the circuit diagram of LM317. This is also 3-pin adjustable variable regulator. Okay, here we have this LM317 needs two resistors. Okay, it needs two resistors R1 and R2 for setting the output voltage. Okay, this here the normally the capacitors are not required. Okay, normally here the capacitors are not required, but it needs two resistors to set the output voltage. When LM317 is placed more than 15 centimeter apart from the output filter, means capacitor need to be needed. Okay, if it is more forward from the output filter, means capacitor C2 of the supply is needed. Okay, capacitor is needed. And input bypass capacitor C1 of 0.1 microfarad or 1 microfarad need to be connected, otherwise capacitor is not needed. Okay, and additional of aluminum and tantalum electrolytic capacitor of range 1 to 1000 microfarad may be connected to the output. Additional of one capacitor is connected to the output, that is aluminum or tantalum electrolytic capacitor. Okay, the unregulated voltage is applied first and it is converted into regulated voltage. Okay, this unregulated voltage is applied at the terminal of VI with respect to the ground, and it may be higher than the required regulator voltage by a value of at least 2 volt. Already we have seen this one. Okay, it should be more than 2 volt. Now the IC develops a typical reference voltage, that is V reference equal to 1.25 volt between the output and adjustment terminals. Okay, this voltage across R1 is resulting in a current flow of I1. Okay, this output voltage, this current flow across R1 resulting in this voltage across R1 resulting in a current flow across R1, current flow of current I1. So I1 is equal to V reference divided by R1. Okay, so here the current I1 is equal to, this I1 is equal to V reference divided by R1, and this current also flows through resistance R2. This I1 current also flows through resistance R2, and the additional amount of current I adjust flows out. Okay, an additional amount of current, that is I adjust flows out of the adjustment terminal of the regulator. Okay, through R2. Through R2 I adjustment current also flows. Thus the net current through R2 is, so the net current through R2 is I2 is equal to I1 plus I adjust. Okay, I2 is equal to I1 plus I adjust. So V2, we know that V2 is equal to I2 into R2. Okay, V2 is equal to I2 into R2. So you substitute now the value of I2 here. So you will get I1 plus I adjust into R2. Okay, so now the net output voltage is equal to, that is V0 is equal to V reference plus V2. Okay, V0 is equal to V reference plus V2. So this V0 is equal to V reference, you can substitute the value of V2 here. So you will get this equation. Okay. Next in the next step you can take this V reference commonly outside. Okay. So you will get V naught equal to V reference into 1 plus R2 divided by R1 plus I adjust into R2. Okay. Now we have obtained the equation of V naught. In the last term of the output voltage, this term is the error term. Okay. Error term with a typical value of 250 microampere. So this term can be neglected. In the output voltage, this last term can be neglected. So our equation can be written as V naught is equal to 1.25, that is V reference into 1 plus R2 divided by R1. Here in this variable voltage regulator, this R1 is connected to the regulator. Okay, this resistance R1 is connected directly to the regulator. V naught is a function of, from this equation we can tell that V naught is a function of R2 and R1. Okay, V naught is a function of R2 and R1. Okay, that is V naught is a function of R2 with a specific value of R1. Okay, is a function of R2 with a specific value of R1, that is 240 ohm. R1 value is 240 ohm. That is the specific value. Okay, here the protection diodes can be connected. Okay, we have two diodes, that is D1 and D2, that is called protection diodes, that can be connected to the regulator circuit when output of capacitors value is greater than 225 microfarad. When the output of capacitors values are greater than 25 microfarad are used. This diodes D1 prevents the capacitor from discharging into the regulator. Okay, this diodes D1 prevent the capacitor from discharging into the regulator. So we have studied about variable voltage regulator, that is LM317. That's all. Thank you.